When installing a 1.5 kilovolt-amps transformer from 480 volts three-phase to 120 volts for a welding machine, the proper grounding and wiring procedures are critical for safety and functionality. The following steps outline the correct method for both the transformer installation and the ground fault circuit interrupter receptacle wiring. Firstly, for the transformer installation, connect the 120 volts neutral, designated as zone, from the transformer to the welding equipment's neutral terminal. Secondly, connect the 120 volts hot wire, designated as X2, from the transformer to the welding equipment's hot terminal. Thirdly, connect the 480 volts three-phase power supply to the appropriate primary terminals on the transformer. Fourthly, and most importantly, bond the transformer's ground conductor, which is typically green or bare copper, directly to the ground conductor within the 480 volts supply circuit. Do not bond the neutral, zone or X2 to the ground conductor at the transformer. The ground conductor is there to provide a path for fault current to return to the source, tripping the overcurrent protection device, such as a circuit breaker, in the event of a ground fault. Now, regarding the installation of the ground fault circuit interrupter receptacle, follow these steps carefully. Firstly, connect the 120 volts hot wire X2 from the transformer to the ground fault circuit interrupter receptacle's line terminal. This terminal is typically identified by a brass or gold colored screw. Secondly, connect the 120 volts neutral wire, zone, from the transformer to the ground fault circuit interrupter receptacle's neutral terminal, which is usually a silver or white colored screw. Thirdly, connect the welding equipment's ground wire to the ground fault circuit interrupter receptacle's ground terminal. This is typically a green or bare copper screw. Fourthly, connect the ground conductor from the 480 volt supply circuit to the ground fault circuit interrupter receptacle's equipment grounding terminal, which is typically another green screw. This ensures that the receptacle is properly grounded back to the main panel. Several additional points must be taken into account. Firstly, it is highly recommended to use a licensed electrician for this installation. Electrical work can be dangerous and requires a thorough understanding of electrical codes and safety procedures. A licensed electrician will ensure that the installation is performed correctly and safely, and that it complies with all applicable electrical codes and regulations. Secondly, verify that the ground fault circuit interrupter receptacle is properly rated for the voltage, in this case 120 volts, and the amperage of the welding equipment being connected. The ground fault circuit interrupter receptacle's rating must be equal to or greater than the maximum current that the welding equipment is expected to draw. Using a ground fault circuit interrupter receptacle with an insufficient rating can lead to overheating and failure, potentially creating a fire hazard. Thirdly, regularly test the ground fault circuit interrupter receptacle to ensure that it is functioning properly. Most ground fault circuit interrupter receptacles have a test button that, when pressed, should trip the receptacle, cutting off the power supply. It is important to perform this test at least once a month to verify that the ground fault circuit interrupter is still working correctly. If the ground fault circuit interrupter fails to trip when the test button is pressed, it should be replaced immediately. Ground fault circuit interrupters are life-saving devices that protect people from electric shock. A ground fault circuit interrupter works by monitoring the current flowing in the hot and neutral conductors. If there is a difference of more than a few milliamperes between these currents, it indicates that some of the current is leaking to ground. This leakage current could be flowing through a person who is in contact with a grounded object in a live wire. When the ground fault circuit interrupter detects this leakage current, it trips the circuit, cutting off the power supply and preventing an electric shock. Ground fault circuit interrupters are required in many areas of the home, such as bathrooms, kitchens, and outdoor locations, where there is a high risk of electric shock. They are also commonly used in industrial and commercial settings to protect workers from electrical hazards. When selecting a ground fault circuit interrupter receptacle, it is important to choose one that is suitable for the intended application. Ground fault circuit interrupter receptacles are available in different amperage ratings and with different features, such as weather resistance for outdoor use. It is also important to choose a ground fault circuit interrupter receptacle that is listed by a recognized testing laboratory such as Underwriters Laboratories to ensure that it meets safety standards. When installing a ground fault circuit interrupter receptacle, it is important to follow the manufacturer's instructions carefully. Ground fault circuit interrupter receptacles are typically installed in place of standard receptacles and are wired in a similar manner. However, it is important to identify the line and load terminals correctly to ensure that the ground fault circuit interrupter receptacle functions properly. The line terminals are connected to the incoming power supply, while the load terminals are connected to the wiring that feeds the downstream receptacles or equipment. When replacing an existing receptacle with a ground fault circuit interrupter receptacle, it is important to turn off the power to the circuit of the circuit breaker panel before starting work. This will prevent electric shock. It is also important to use a voltage tester to verify that the power is off before touching any wires. Once the power is off, the existing receptacle can be removed and the ground fault circuit interrupter receptacle can be installed. Be sure to connect the wires to the correct terminals and the ground fault circuit interrupter receptacle and to tighten the screws securely. After the ground fault circuit interrupter receptacle is installed, turn the power back on at the circuit breaker panel and test the ground fault circuit interrupter receptacle to ensure that it is functioning properly. Press the test button on the ground fault circuit interrupter receptacle. The ground fault circuit interrupter receptacle should trip, cutting off the power supply. If the ground fault circuit interrupter receptacle does not trip, it is not functioning properly and should be replaced. Grounding is a critical aspect of electrical safety. It provides a low impedance path for fault current to return to the source, allowing the overcurrent protection device to trip and clear the fault. Without proper grounding, fault current can flow through unintended paths, such as through a person, causing electric shock. The National Electrical Code, or NEC, provides detailed requirements for grounding and bonding electrical systems. Article 250 of the NEC covers grounding and bonding. It specifies the types of grounding systems that are permitted, the methods for grounding equipment, and the requirements for bonding different parts of the electrical system together. One of the key requirements of the NEC is that all metal enclosures, such as electrical panels, junction boxes, and equipment housings, must be grounded. This is typically accomplished by connecting a grounding conductor to the metal enclosure and running it back to the main grounding electrode system. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The NEC also requires that all conductive parts of the electrical system that are likely to become energized be bonded together. This includes metal conduits, cable trays, and equipment grounding conductors. Bonding helps to ensure that all parts of the electrical system are at the same potential, reducing the risk of electric shock. In addition to grounding and bonding, overcurrent protection is another important aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When an overcurrent occurs, the overcurrent protection device trips, cutting off the power supply and preventing damage to the electrical system. The NEC specifies the types of overcurrent protection devices that are permitted for different applications. It also specifies the ampacity of the conductors that must be used in each circuit. The ampacity of a conductor is the maximum amount of current that it can safely carry. Overcurrent protection devices must be sized to protect the conductors from overheating. When selecting overcurrent protection devices, it is important to consider the type of load that the circuit will be serving. Some loads, such as motors, require special types of overcurrent protection devices that are designed to handle the inrush current that occurs when the motor starts. The NEC also requires that all electrical equipment be listed by a recognized testing laboratory. Listing indicates that the equipment has been tested and found to meet safety standards. When installing electrical equipment, it is important to follow the manufacturer's instructions carefully. This will help to ensure that the equipment is installed correctly and safely. It is also important to inspect electrical equipment regularly for signs of damage or wear. Damaged or worn electrical equipment should be repaired or replaced immediately. Electrical safety is a critical concern for everyone. By following the safety precautions outlined in this guide, one can significantly reduce the risk of electric shock and other electrical hazards. Always remember to consult with a licensed electrician for any electrical work, especially when dealing with high voltage systems. Ground fault circuit interrupters are especially important in locations where electrical equipment may come into contact with water. This includes bathrooms, kitchens, laundry rooms, and outdoor areas. Ground fault circuit interrupters can also be used to protect individual appliances such as hair dryers, curling irons, and portable heaters. When using portable electrical equipment, it is important to inspect the cords and plugs for damage before each use. Damaged cords and plugs can create a shock hazard. Never use electrical equipment near water. If electrical equipment falls into water, do not touch it. Turn off the power at the circuit breaker panel and then retrieve the equipment. If you experience an electric shock, seek medical attention immediately. Electric shock can cause serious injury or death. Remember that electricity can be dangerous, but by following these guidelines and best practices, along with consulting a qualified electrician, you can help protect yourself and others from electrical hazards.